How many are we doing?
All right, so let's see. This is 5th period. This will be the multiples of 3 video. If you're looking for the other videos, they're posted elsewhere, and I think they're nicely labeled so you can figure out where to find whatever you're looking for. All right, number 3. The volume of a cylindrical tin can with a top and a bottom is to be 16 pi cubic inches. There's my can. Volume is 16 pi. That already sounds like a secondary equation because I'm not maximizing or minimizing anything. The volume is 16 pi. If a minimum amount of tin is to be used to construct the can, what must be the height in inches of the can? Find the height. The formula for the volume of a cylinder is pi r squared h. So I can get rid of the pi's. R squared h equals 16. Amount of tin. So what's the geometry word for what describes the amount of tin we would need? Surface area. So I want the surface area of that cylinder. Well, it's got circles on the top and the bottom. So that would be 2 times pi r squared, 2 circles. Plus, right, this is how you don't really memorize the side surface area. You think about, well, if we unrolled it, it has a height, and then this side would be the circumference, which is 2 pi r. So that area then is 2 pi r h. Okay, so volume is 16 pi, got that. Surface area, that's my primary equation because that's what I want to minimize. Which means I'd like to get that, or I'll need to take a derivative, but not yet. Why not yet? Why don't I want to take a derivative of that right now? I can substitute first. What would be the problem with trying to take a derivative of this thing right now? There's 2 variables. So that would be really ugly. I mean, it's possible, but it'd be really ugly. So it'd be better if I could solve for r or h. You can do either one. It sure looks like h would be easier to solve for. So I'm going to do 16 over r squared. So surface area is 2 pi r squared plus 2 pi r times 16 over r squared. So, well, I'm ready to take a derivative, sort of, like there's only one variable, but I would like to clean that up a little bit first. 2 pi r squared plus 32 pi, and then r in the bottom, but since I know a derivative's coming, I'm going to rewrite it as r to the negative 1. I'm far more likely to get that derivative correct if I write it like that. Okay, so the derivative of surface area prime, 4 pi r plus, minus 32 pi r to the negative 2. Seems kind of weird, but that's the only calculus step in the whole problem. Set it equal to 0, because whatever it looks like, I have no idea what it looks like, but I know maxes and mins happen at horizontal tangent lines where the slope is 0. So take a derivative, set it equal to 0, and we'll figure out what r is. Did I make a mistake somewhere? Thank you. Okay, so we can move one of those over. Run out of room here. So 4 pi r equals 32 pi over r squared. pi's will go away. R cubed, if I multiply both sides by r squared, divide both sides by 4. That was convenient of them. R equals 2. I'm a little surprised that's not one of my answer choices. But it didn't ask for the R, it asked for the height. So somewhere in that nest of work, I should have an equation for height that I can use. 16 over r squared. So 16 over 4 is 4. So my height is 4. That's the optimized type problem. There's 3 of those on the test. The rest are motion problems, and the rest of the review worksheet is motion problems. Number 6, with calculator, which is good because that's a weird looking formula there. The position of an object attached to a spring is given by that thing. T is time in seconds. In the first 4 seconds, so that's sort of information about the window I want to look at. How many times is the velocity equal to 0? How many times is the velocity equal to 0? Okay, well, there's a couple ways to do this problem. I know that velocity is the derivative of the position. So one way to do this, in my mind there's 2 ways to do this. I can take a derivative by hand and then set that derivative equal to 0. Some of you are shaking your head like, I don't want to take a derivative by hand. Okay, that's fine. That means if I don't want to take a derivative, then I somehow have to figure out from this graph that graph, I know my window is 0 to 4, at least my X window. My Y window I don't really know. I'll go -5 to 5. Actually, wait a minute. I don't know, but if my coefficients are 1/6 and 1/4, then probably -1 to 1 will work. Because 1/6 and 1/4, that's pretty small.
But what'd you put the Y max to?
I did 1 to 1, -1 to 1. Okay, so I'm looking at the graph of velocity. No, I'm looking at the graph of position. And it's asking me questions of where the velocity is equal to 0. So again, I could take a derivative by hand and set that equal to 0 and even let the calculator do it. But how can I look at this picture, the picture of position, and know where the velocity is 0? Where what changes sign? The slope changes sign. So what's another word for where the slope changes signs? The maximums and the minimums. So I can just look and see right here the slope changes signs, or I could just phrase it this way. My derivative is 0 at the maximums and minimums. So really I can just count the maximums and minimums. So how many times, that's just the count. The number of times dy dt equals 0. So the slope equals 0. And the slope equals 0 at the maximums and the minimums. So as long as my window is 0 to 4, make sure I'm not overcounting or undercounting, then I'm just counting the maximums and the minimums. 1, 2, 3, 4, 5, 6. 6. 3 maxes, 3 mins, but 6 places where the slope is 0, which means the velocity is 0.
On the calculator part, we need to show something like what's up there to get credit.
Well, on the multiple choice part, no. on a free response part, I would want to see. I wouldn't need to see all of this, but I would want to see something like that. But on multiple choice, you wouldn't have to write anything really, so you could get by with guessing. Again, sometimes I do give partial credit, so if you had this written down, if it's a 4-point question, maybe I can give you 2 points because you at least I thought you knew what you were looking for. So, yeah, I would say show work even on multiple choice because there is partial credit to be had. Number 9. Okay, no calculator. The position of a particle moving along the x-axis is given by a twice differentiable function. Okay, x of 2 is less than 0, x prime of 2 is less than 0, x double prime of 2 is less than 0. Which of the following statements must be true about time equals 2? Okay, x of 2 is less than 0. So what does that mean? It means the position is negative. X prime of 2 is less than 0. What does that mean? Okay, it could mean the slope is decreasing. No, not the slope is decreasing, but the slope is negative. But it also means the velocity is negative, which means we're moving left. And you're right, that means dx dt is negative. And then the second derivative is also negative. That would mean the acceleration is negative. Okay, so what are my options here? Moving toward the origin or away from the origin, decreasing speed, increasing speed. Okay, the speed thing I can definitely get, because if velocity is negative and acceleration is negative, what does that mean? Increasing speed. Like increasing in the negative direction, but increasing speed. So I can throw out A and C. So my next question then is, are we moving toward the origin or away from the origin? Well, our position is negative, so our position is left of the origin. Our velocity is negative, leftward, and it's also just speeding up, so it's like getting faster. So you draw a picture, and I think it becomes obvious that we're moving away from the origin at an increasing speed. That was kind of a tricky question, because you needed the velocity negative, acceleration negative to give you increasing speed. Position negative and velocity negative says away from the origin. So that was a lot of stuff going on in that one. Victor?
If it was increasing speed, would it just be opposite acceleration and velocity?
Correct. If V and A have opposite signs, then it is decreasing in speed. Number 12. The position of a particle moving along a line is given by this thing. For what values of t is the speed increasing? That's kind of annoying because speed increasing means I have to think about V and A having the same sign. So speed increasing, I think I need the number line for velocity and the number line for acceleration to look for the overlaps of the same sign. So V is 6t squared minus 48t plus 90. And I guess while I'm in the derivative taking mood, the second derivative, the acceleration, would be 12t minus 48. going to kind of bail out and do the easy one first. So the acceleration is 0 at time 4. So that I can use that to set up my acceleration. I feel like I'm going out of order doing this, so I don't know if this is good or not. My acceleration number line. So if I plug in 3, I get a negative number. And if I plug in 5, 12 times 5 minus 48 is a positive number. So there's my acceleration picture. I also need a velocity picture. So let's see, if I factor out a 6, it's nice when they rig these problems to work out for us. So t minus 5 and t minus 3. So t equals 5 and t equals 3. Again, I'm keeping an eye on my acceleration picture. I'm trying to keep things lined up here. Okay, if I plug in 2, so something less than 3, I get negative times negative is positive. If I'm pressed for time, I could alternate. If I plug in 4, I get negative times positive is negative. And if I plug in something bigger than 5, I get positive times positive, so that's positive. Okay, what was I looking for here? Speed increasing, V and A have the same sign. So let's see, they start out different signs. And then right here, they're both negative. So from 3 to 4. And then it's negative positive from 4 to 5. And then from 5 onward, they have the same sign. So from 3 to 4, and from 5 to infinity. And I wrote mine in integral notation, but I can find that over here as inequality notation, 3 to 4 and greater than 5. So answer E. In my favorite Facebook group, this came up just yesterday. I guess all the calculus teachers are kind of at the same spot. Someone asked, on a free response question, are students expected to give the answer in interval notation or inequality notation? And the answer was either one, whatever you like. With the caveat that in multiple choice, we get to pick which format you use, so make sure you're familiar with both. I don't think that's a big deal, but if you're answering a free response question, you can use either form is fine. Yeah. Anything else on number 12?
What form is it going to be on the test?